Hello and welcome. Today we're going to take a look at the Open Learning Initiative, Chapter 4, uh, Way of Dealing with Problems. Now, Chapter 4 is a rather interesting one because we do a lot of new rules, so we're going to slowly work our way through this. So here we have the practice quiz problems. This is page 60, and let's take a look at what we have going on. All right. So here we have which of each of the following groups of formula contain a pair of formula, one of which is a positive subformula of the other. Indicate the pair of formula and specify which is the positive subformula of the other. So if you don't know what a formula is, or what a subformula is, or what any of those things are, that's the go back and look at the chapter part of things. Let's take a look here. It appears that this is our formula. So A should be the positive subformula of this entire thing. Let's go ahead and check our answer. That is correct. Right, so why did I pick A instead of B? Well, because positive subformula is something that ought to be true, right? Now, what we have in this first part here, if B then C, keep in mind that both of those could be false, right? B could be false and C could be false, and the conditional would still be true. But because we have the conjunction, so and A, the A part has to be true. So that's how you know those sorts of things. Let me make sure the phone is not going to disturb us. Let's take a look at the next one here. Which of the three formulas is a positive, which of these three formula is a positive subformula of another of the three? So not F here should be the positive subformula of the entire thing. The reason for that is if the consequent is true, then the antecedent could be true or false, and it doesn't matter. But if the antecedent, the G in this case, is true, then the whole formula could be false if not F happens to be false. So let's see if we got that right. That is correct. Now let's take a look at one more here really quick. Oh Lord, which subformula of this whole mess of things are positive? Okay, so because the top level function is this conditional, everything after that needs to be true, right? For the same reason as the example above. I think the whole formula is technically a positive subformula of itself, so we're going to check that. So we have not C and N, or M or Q or R. That has to be true. Now I need one of these two here to be true, right? Either the not C and N, or the M or Q or R. So I think I can actually put both of them down. And then inside of this can either be this or it can be R. And then if I want this subformula here to be true because it is what's the word I'm looking for? It's a conjunction, then I need not C and N to be true. C can't be true because if C were true, then this would be false. And then I need, actually, I think that's it. I don't know that I have to have other things be true. Let's take a look at what happens. off the top of my head. Okay, it's incorrect, but let's find out why. You missed some. Only D and C are not positive subformulas. Okay, I see. So technically, any of these being a positive subformula would work. So when they're asking for a positive subformula, what they want to see is all the things that could be true, or sort of that would need to be uh, true if the whole thing ended up being true. Now, again, because this is a conditional about D, we don't care. Obviously, about the C, C can't be true because then this would make a negation, and that would make this entire thing over here false, and then you're not positive about that. Right, so you got to sort of work through all the things that could be it. So this should be it. Let's take a look. And there we go. So only the C and D are the not positive subformulas of this entire mess. All right, so there we have that. Let's take a look at our lab problems. So we have a couple of exercises here. Derivation for exercise 1, exercise 2, exercise exercise 5. All the rest will be sort of repeat. All right, so let's do something simple enough with the starter one. So we need to fill in the truth table for this argument in order to determine its validity. Actually, maybe a little fuzzy. All right. So if P and Q are true, that's our premise. Can our conclusion be Q? That should be pretty straightforward. Let's take a look. Right, this is just conjunction, so yes. If P and Q are, this conjunction doesn't work because in a conjunction, both conjuncts have to be true. That would be false. If P is false, then P and Q has to be false. And then if neither of them is true, then obviously the conjunction has to be false. So classify the argument by clicking on the appropriate button. Well, whenever P and Q is true, Q is also true. But here P and Q is false, and then we have Q being true. I don't think this is valid. I feel like I must have missed something. Oh, I clicked on the wrong one. See, this is why I should always pay attention. Right. There is nowhere where P and Q together is true, and then the conclusion, in this case, P, is false. Right? Because we only have one place where P and Q is true. That's a place where P is also true. So, ta-da, it is a valid argument. Great. Let's take a look at the second set of derivations here. This is from exercise 2. So we have to complete the following derivation using the rules provided. So let's take a look at what we have going on. Okay, so we have 3 premises, and here is the goal that we are trying to get to. So what this goal says is if we start off with a P, then we can get both not S and we can get R. So can we do that? Well, just taking a look at these premises, we can see that we have P, Q, and P, R. And with a conjunction like this, we can take the conjunction apart and get each of the conjuncts out by itself. So if P and Q is true, that means that I have P and I have Q, and I can get them independently. So I can definitely have P as my antecedent because that is true. So then can I get not S and can I get R? Well, I should be able to. Since I can get Q here from premise 1, that means I can get line 3 here, premise 3. Since I have the antecedent, it will give me the consequence. So I'll get a not S out of it. There's that. And I can just pull R out from here. So what we can do is we click on the thing that we're working on, and we're going to say, we're going to do a conditional introduction. In this case, we're going to work in reverse, right? It's always a useful strategy. Start with what it is that you're supposed to get, and then sort of work it backwards. Like, what did I need to have to make this work? So we'll hit apply, and it gives us this kind of a setup. Okay. So notice that what I have happening here. Oh, okay. We don't need those options. Oh, away. Awesome. So we're saying here, look, let's just go ahead and assume that P is true. Great. Now we're going to get R out of this setup. So we're going to select our premise 2. Okay, so first we're going to select our little box here, the subderivation, as a target. That's where stuff is going on. And we're going to take this P and R. I guess we're not. We're going to eliminate left, I think. No, we need to eliminate right. There we go. We're going to click on the P and R. So now when we click apply, the letter R should drop out by itself. There it is. So now we have that. Now we just need to get this not S. To get that, first we need to get a Q in here so that we can take out the antecedent Q up here. So again, we're going to select the box as a target. We're going to select the right conjunction elimination like this. Then we're going to select which conjunction we want to take apart, and that's our premise 1. So when we apply this, Q alone should drop out. There it is. Awesome. Then we should be able to select our subderivation here as a target. We are going to do conditional elimination. And now we need to select the conditional statement, and then we need to select the antecedent that we're using. There we go. So now not S should drop out. Okay. So now I need to create, as the last step, I need to create my goal here. So how do I get this goal? Well, this is a conjunction introduction. So I click on the conjunction introduction button over here. And first I select what's going to be on the left side. So that's not S. And then I select what's going to be on the right side of the conjunction, which is R. There we go. And then I hit apply. Okay. So here's what this problem looks like now. I had the first 3 lines as my premises, and I had the last line as my conclusion. What I did is I set up a situation where I'm going to assume that I can get P, because I know I can get P. And then if I make that assumption, what else can I do? Well, then I can pull R out, and I can pull Q out. And when I pull out Q, I can get not S. And so if I assume P, I can also get not S and R. So that's what this statement is. If P is true, and I know it is, then I can get to not S and R. That's sort of the straightforward version of that, or straightforward-ish. All right. You might have noticed there's a cool thing here on the right-hand side of your screen. As you click on each of these options, it will sort of tell you what's happening forwards, backwards. Well, this one can't be applied backwards. This one can. And it will show you, I'll show you that on the next derivation, how that sort of pops up so you can see it nicely. All right, let's take a look at exercise 5, problem 1. This one looks like it's going to be fun, right? Complete derivation. All right, so again, we have 3 premises and we have a conclusion. So our conclusion is if we assume A, then if B, then C, then D. Okay, so it's all conditionals all the way down. And that should give you a hint that we're going to see a number of subderivations that we're about to get out of this. All right. So let's take a look. So the first thing we want to do is do conditional introduction. We're going to work backwards. So you see now as I've clicked this on this right-hand side here, you're going to see what's happening, right? If I have my conclusion, it will give me my starting assumption, which is the first part here, and then I have to get to this conclusion here, the P1 on the side here. Right, so yes, we want to do that. Okay, that's very nice and neat. Now I have this set up here, which is another conditional. Now, neat thing you can do is you can do another backwards conditional introduction. In this case, B then C is going to move my new sub-assumption, and D is going to be my conclusion there. Okay, now, if we take a look up, we'll notice that I do, in fact, have this neat little thing here. So I can see that if I have this B then C happening right up here, and B then C is the antecedent, so I could get D or E to drop out of it. Great. Another thing I could do here is I could get this C or A. How would I do that? Well, I have A. And remember, you can always introduce a disjunct in, just sort of for funsies. And that's because if you think about it, it's not incorrect if somebody tells you like, hey, today's Tuesday, that you could just throw in like, or I am Santa Claus. And so long as one of those statements is true, the disjunction is true. So it doesn't really matter what you throw in. So I happen to know A, or I'm assuming A. I could just sort of add or C to it for fun, and that's about it. So let's take a look at what we have. So we are going to pick this box here as my target. We are going to do disjunction introduction on the left for A. Now, when we click apply, we're going to get a box that pops up. And they're asking us, what do we want this to look like at the end, right? So we want it to look like C or A. Both parentheses. I'm not sure what I should be using parentheses here, but let's find out. Oh, I see. Never mind. Never mind. Let's throw that one. Oh, wait, I can't throw that line out. There has to be, yeah, there we go, undo. My bad. So when they ask you to enter in the formula, they're just asking you to punch in what you want to be on the left-hand side of A, this in this case. So we can just put in capital letter C. There we go. So now we have C or A, just as we do up here. So this box is still going to be our target. We are going to do a disjunction, conditional elimination. And first we pick the disjunction itself, not disjunction, sorry, the conditional itself, and we pick the antecedent here, and we apply. There we go. So what happens here is if I assume A, then I'm supposed to get to this if B, then C, then D. Once I have that, I can pull that out into assume B, then C. That will give me D. And then I can just go ahead and add in a disjunct on the A. So I get C or A. That gives me the antecedent on my third premise. That allows me to conclude to the D as per premise 3 and ta-da. So now you have the whole way of getting there. It's again, it seems relatively straightforward, but let's see if we can throw in any other things that we might want to look at, just so we don't have much confusion. Here we go. Let's do exercise 3, problem 2, and then we'll call it a day. We'll do this one because it's kind of fun in that think your way through all of these things. Obviously, to solve the problem. So we have a bunch of things going on, and we're just trying to get this conclusion, right? K or L. Now, here's the deal. When you have a disjunction as your conclusion, you only need to get 1/2 of that disjunction, and the rest of it you just sort of throw in there, right? That's the or something else. It doesn't matter what that something else is. So we have to get to either K or we have to get to L, right? But looking at what we have as our premises, we have a disjunction as our premise 1. That's a top level function. And then we have a conditional as our second premise. If I can prove R, that will give me access to L, right? If I know that R is through, then I can get rid of this R here, and I can just open up the P and the L, that gives me the L, and then I get the K. Or I can do this, mess up here and do this disjunction, and then see what happens. So I think actually here, what we can do is we can do disjunction elimination. And this is what we want to do it on. Okay. And I need it. So first you pick which disjunction you're working on, and then you pick what is the target that you're trying to get to. And the rule for taking disjuncts apart is you have to start off with both the sides in separate set of assumptions. So in this case, P and K on one hand and then R on the other. And you have to be able to come to the same conclusion. That's how you know that a disjunct works. So when we do this, we're going to get 2 little sub boxes just like this. Now we have to solve both of them. All right, so this is actually pretty easy, right? We get P and K. Because this is a conjunction, I can pull K out. And then I'll just add this disjunction with L, which I don't need to have from anywhere else. I'll just pull it out of thin air. So let's do that. First, we select this box as a target. We're going to do the conjunction elimination on the right on P and K. Yes, that will give us K. You can always, by the way, if you're not sure whether it's left or right, you can always take a look over here on the side. It will tell you what's going on. So you hit apply, that gives us K. So we select this box as our target. We're going to do disjunction introduction to the right of the thing that we already have. And going to the right of this K. So when we hit apply, they'll ask us to enter something. And in this case, we just need the L to be entered to the right of the letter K. And there we go. Pretty simple. Now, if we have an R, we have to get to K or L. Well, I don't have a way of getting K in here, but I do have a way of using this premise 2 to give me an L. And then I'll just enter the K as a disjunction introduction to the left. So we pick the box, and we want to do a conditional elimination. That's this button here. This is the conditional that we want to take apart. And here's our antecedent, that's the letter R, and that will give us P and L as the outcome. Great. I need to pull out L. So I'm working again in this box. It's a conjunction elimination of the right conjunct. If I select that, hit apply, that will give me L. And now, still working in the same box, I need a disjunction introduction to the left, right? Because it's supposed to be K or L, so the K comes first. And I need to do that to the L. So I enter in a K, that gives me K or L, and ta-da, there you go. So with these two premises, I can get to this conclusion, and I can prove that's the case, because if I take my first premise and I check, it turns out that both sides of the disjunction can give me the exact same conclusion, which is K or L. And ta-da, there we go. That's all done. All right, so that's it. If you guys have any questions, comments, or concerns, please feel free to leave it in the comments or email me, and I will see all of you next time. Take care.